Good afternoon, everyone. I'd like to thank you for joining us for our webinar today. We'll begin now that it's 4 o'clock. My name is Melissa. I'm the Program Manager for the National Ocean Sciences Bowl, and I'd like to thank you for joining us today for our webinar series. I'm sure most of you are associated with the National Ocean Sciences Bowl, but in case you're not, the NOSB is an academic competition for students who are in high school. They prepare all year to compete in the regional bowls, which happen mostly in February, and then those winners from the regional bowls go on to compete at the nationals in April. And this year we're hosting our nationals competition in Long Beach, Mississippi. Therefore, we decided that our 2020 theme would relate to the Gulf of Mexico and the research, research economy and cultural norms around the Gulf of Mexico. And so our webinar series will be highlighting all things Gulf of Mexico this year. So today's webinar will be on sea level rise, a topic that should be pretty interesting for most of us who live along the coast. We typically hold these webinar series for our coaches. It's a way to prepare the students for competitions. The coaches watch the webinar and then can go back to their teams and explain what they've learned. But we also open this up to any interested educator or individual based on the topic. So if you're not with the NOSB, we really do appreciate that you joined us today. And if you are with the NOSB, just know that there will be questions based on this competition filtered in, or based on this webinar into the competition. So you may learn something today that will help your students when they compete. Just to give you a little bit of a background on how the webinar works, our presenters have up to an hour to present on their topic, and then we will do a 30-minute Q&A session. So you should all see that in Zoom there's a Zoom group chat box. Throughout the presentation, that is where we would like you to enter your questions for our presenters today. I have you all muted simply so we don't disturb the presenters with background noise. So when their presentation is up and we move into the Q&A session, I will read those questions aloud to them for them to answer then. So like I said, at any time, you can go ahead and enter your questions in that chat box, or I'll remind you again at the end of their presentation to do so. So I'm going to turn it over to our presenters. We have 4 speakers today from the Northern Gulf of Mexico Sentinel Site Cooperative. And they're going to present on the Gulf of Mexico and preparing communities for sea level rise. I'm going to let them introduce themselves as they begin their presentation. So I turn it over to you, ladies.
Thank you, Melissa. We are excited to have the opportunity to talk with everyone today about what we do and how we do it. And like she said, we are the Northern Gulf of Mexico Sentinel Site Cooperative, and we'll be sharing information about preparing communities for sea level rise.
Hey everybody, so to tell you a little bit about what the Northern Gulf of Mexico Sentinel Site Cooperative is, we are a partnership that's focused on sea level rise. And if you look at all these many logos, it gives you an idea of not only there are a lot of people in this partnership, but that they range a wide variety of things. So all the way from the science, through service, through stewardship, which is just a continuum of action around sea level rise. And the science are people who are observing, doing research, getting all the information. Service are people who are helping to translate that information out, and then stewardship are people who are making decisions, whether it's people who work with natural resources or with our coastal communities. And we primarily focus in the Northern Gulf of Mexico in these blue shaded areas, but that's not the only area where we have lots of partners that work across the whole Gulf and in other parts of the U.S. In addition to our partners, we have a few people that are dedicated staff working on the cooperative and helping to provide momentum to this partnership. So we have Sonia Vedral, who you've already heard from, and then we have myself, Renee, Collini, Mikaela and Sara, both of whom you'll hear from in a little bit. And if you notice the little icons at the bottom, we all work on different things. Sonia is an education specialist. I work on building the partnership and expanding it. Mikaela is a communication specialist, and Sara is a wetland specialist. So there's all types of ways that we can integrate science and ways you can work to help move science forward. So that all sounds really nice, but it's hard to imagine what that actually means we do. And so to give a better sense of what this partnership is trying to accomplish and what the staff are working on every day is, you see all these little shapes and pieces. You can think of each of these as a different thing that NOAA or other researchers have that's information about sea level rise. Maybe this one is a report, and this one is observing data, and maybe this one is a tool on sea level rise, but there's a lot of it. It can be overwhelming and feel a little bit disjointed. And so the partnership works to put all these things together in a way that helps you move forward. And so the way that we actually do this is through three primary things. We help people get access to sea level rise science and information. Then, of course, we help them use it, because just because you have access doesn't mean that it's easy to use. And then once we help people find the science, understand how to use it, then we actually help with implementation, whether that's through conversations or executing projects.
And so before we talk about sea level rise, to frame where we are in that conversation, sea level is the starting point of water depth, and waves and tides affect our perception of sea level, but they are not included when measuring over a long period of time. And we are experiencing sea level rise because we are also experiencing climate change. To use the heat trapping blanket metaphor, when we burn fossil fuels like coal and gas, we pump carbon dioxide into the atmosphere. And as this carbon dioxide builds up, it creates a blanket around Earth. This thick blanket around Earth traps heat, and this trapped heat warms up our atmosphere as well as our oceans. And so with a warming atmosphere, it means that we are having a warming ocean. And this warming ocean drives the two main causes of sea level rise. One of them is melting land ice. And so like glaciers and polar ice caps, as the atmosphere gets warm, this ice melts and it flows into the ocean. And that added volume of water leads to sea level rise. Floating sea ice does not increase in sea level rise, just like ice cubes in your glass doesn't make your glass overflow. The other cause of sea level rise is thermal expansion of water. And as water warms, its molecules become more energetic, and this causes the water to expand and take up more room. And because our oceans are absorbing heat from Earth's atmosphere, we're seeing both melting land ice and thermal expansion of water contribute to sea level rise.
And we know that the seas are going up because we've been measuring it in some places for over 100 years. And we do this in two ways. So there's tide stations, which are physical installations on our coastlines that are measuring how the water's changing. And then we also have satellites, which cover much bigger spaces. The satellites have been contributing for their more recent technology. The tide stations have been there for, like I said, in some places more than 100 years. The satellites are more in the past 20 years or so. But from that information that they're gathering, we know not only are seas going up, but they're going up different rates in different places in the US and across the globe. And so if you look at this website, which anyone can go to, here's the address. It shows us the rate at which sea levels have gone up historically. And you can see that not only are these arrows different sizes, which indicate different rates of sea level rise, but they're also sometimes going down even instead of up. So in certain areas up here, you can see that the sea levels are actually dropping. And in the Gulf, we've got a big range of different rates of sea level rise. And this is known as relative sea level rise. Sometimes you've heard about global projections, and that's what the average is around the whole globe. But you can see that in lots of places, particularly in the Gulf in the US, it's actually higher than that global average is. And the reason that sea level rise can look different in different places is in part because of how the land itself actually moves. So if you look at this picture here and you see the land and you think, okay, well, if the land goes down, what can cause that? Some of it is sediment compaction. So the actual sediment itself can get closer together. Also, if you pull out oil and natural gas, that leaves behind space that will then compress. And the same thing happens if you pump out groundwater, say for agriculture, that also leaves airspace that will compress. And so the overall effect is that the land itself is lower. And so when that happens, it makes the sea level seem higher. Another effect that causes the land to move is actually changes based on the last glacier period. And so if you have this big heavy ice sheet that's pushing down on the land here is lower, and then the land on the edges is actually pushed up higher. If you think about when you put your head on a pillow and the edges of the pillow go up, but now that the glaciers are retreating, we see some of these land areas that were pushed up are going down, and some of these areas are going up. So this is sort of what's happening in the Alaska area, but say the island of New York or in the Gulf, we're seeing some of these effects. And so like I said, if you look at this picture, this dotted line is where that land started, and now here's where it is, and then you have sea level coming up. If the land had stayed where it was, the amount of sea level would not have seemed the same. The other thing is that with climate change and with sea level rise, water moves differently and in different places. So if you look at this graphic here, each of these visuals is a map of the Northern Hemisphere, and you can see that each one represents a different glacier and how it will affect sea level rise as it melts. So the redder it is, the more it'll be increasing sea level rise as compared to the average. And again, if you look at the Gulf, lots of red and lots of orange, but see for this one with median glaciers in Alaska, it's actually the opposite effect. So the two things that make relative sea level look different in different places are vertical land motion and then changes in how and where the water moves. And this is really important when we talk about preparing our communities for sea level rise. And so when you're looking ahead to what you might be planning for and dealing with, we use these projections. So it's time across the x-axis and it's feet of sea level rise on the y-axis. And then there's these different scenarios that may occur. So the low scenario all the way to this extreme scenario. This is actually projections for Dauphin Island, Alabama, which is a small island in the northern part of the Gulf. But these X's are what projections are for the global average. And so you can see there's a difference there between what the global average projects and what's happening on Dauphin Island. And it's important to account for these changes when you're planning.
And these small rise, the small bit of sea level rise does lead to big changes. And so in this graphic, you can see that with a little bit of sea level rise, it's changing the way the water moves on the coast and can actually change the levels of erosion. And so one of the major impacts of sea level rise is that it is changing the shoreline. And then if you have storm surge from a hurricane or a strong storm that comes through, this water can reach even farther inland with just that little bit of sea level rise. And sea level rise impacts all types of shorelines, not just sandy beach ones, and we'll see a little bit more of that in a few slides on. So sea level rise is making existing hazards worse. So storm surge in that image before, as a hurricane comes towards land, it can push water farther inland, and with sea level rise, that water can go farther in. There's also high tide flooding, where during a high tide, where water is already coming farther up, with sea level it can go even farther, especially during spring tides, which those are really high tides, or the king tides, where water can potentially impact coastal roads or coastal homes. Sea level rise increases erosion along coastlines, as well as leads to saltwater intrusion, where saltwater comes in mixes with fresh water sources, potentially aquifers or underground water, which leads to contamination of that water supply, as well as stormwater management. A lot of storm drain systems are gravity fed to a water outlet. And so if sea level rise causes the outlet to be covered by water, maybe just during a high tide or more often, when water lands in a street and goes down the storm drain, it is not able to be fed out, and so it backs up onto our roads and in our communities. And so the effect of sea level rise on our communities is that it impacts our economies. It changes how people might be able to get to certain locations around beaches and coastlines, as well as the money that can be spent there. It impacts our ecosystems, where our plants and animals along the coast live. It impacts our infrastructure, buildings and roads, as well as public health. Floodwater from sea level rise can pose risks for health and impacts public services like drinking water, potentially from saltwater intrusion, as well as access for police and hospitals to reach our communities.
And just to give you a couple examples of how this not only affects our communities on the coastline, but it also can have impacts in the central part of our country, I'm going to go through a couple examples of how the coastal economy can impact the country. And so the first is just looking at these economic numbers from ports and shipping from 2018. Over $300 billion were contributed to federal, state, and local tax revenues, which are then used to provide services for our constituents here in the U.S. Over $1 trillion in wages and local consumption were provided. In total, this was more than a quarter of the gross domestic product for the U.S. in 2018. So you can see there'd be lots of ramifications and lots of revenue streams that would be impacted if sea level rise begins to interfere with these industries. Again, if you look to fishing, so these are numbers from 2016, there's over $200 billion in sales, over 1 million jobs provided by this industry, and that's not just on the coast. This also includes jobs up the whole supply chain. So we know people in Ohio and in Kansas also eat seafood, and there are people that transport the fish there. There are people who cook the fish there, who sell it there. And then, of course, over $1 billion to the gross domestic product for the U.S. in 2016. So again, a major contributor to the national wealth and resources that we have. And then the sort of the reverse of that is thinking about the culture that we have on the coast. We're not shy about how great it is here. We've got boating, we've got beaching, we've got fishing, we've got great food and adventures, and people come here with their families and their kids and their friends to celebrate and experience this. And we can see this because on the coast, tourism and recreation counts for, again, over a quarter of the coastal GDP. 72% of coastal employment comes from recreation and tourism, and almost half of the wages paid come from this. And so we know that people enjoy coming to the coast. And so as sea levels begins to impact our communities and our economies, these will also be things that won't be as available both to us and people who don't live on the coast. Another way you can think about this, or a step further, is we start looking at how these communities might be impacted. And so this graphic is a little busy. I'm going to walk you through it. On the y-axis for all 4 of these graphs, you have people at risk to sea level rise. And then across the x-axis, you have social vulnerability. And so each bar represents a different category of social vulnerability, going from lowest to highest. So the people on this end are very socially vulnerable in addition to being at risk to sea level rise. And so you can look at these 4 areas of the country, and one thing that jumps out right away is that the Gulf has a lot of people that are at risk to sea level rise. Then as you zoom in, you actually notice that these bars have different colors, and those colors represent different strategies to adapting to sea level rise. And in the Gulf, we have a lot of that light blue, that projection of people having to abandon instead of armoring or nourishing their shorelines. And that's a very different story than the rest of the country. And so the important takeaway, this is from a 2013 paper by Martinek et al. The important thing is that we can change this. We have lots of solutions and strategies that we can employ to be ready for and adapt to sea level rise. And so we're not here to doom and gloom. We're here to talk about what it is we can do to change the story.
And so 3 of the ways that we are looking at today to change the story, 3 solutions for adapting to sea level rise. One is natural solutions, one is ordinance and policy solutions, and then the last is community planning and bringing that all together. And so we'll go through each of these solutions and what's involved. For natural solutions to sea level rise, this is looking at the things that are naturally growing along the coast and seeing what those are, what services they provide, and how we might be able to use them. So here on the Gulf Coast, where we talk about natural solutions to sea level rise, a huge part of that is wetlands. So we have lots of different kinds of wetlands on the Gulf, and this list here is just some of them, not all of them. We have tidal fresh marshes, and so these are ones that are fed by things like rivers, where it's a lot of freshwater input. Salt marshes, so the opposite, ones that are really salty. These might be right on the Gulf or very nearby the Gulf, so they get a lot of salt water from there. We have riverine fresh marshes. As the name suggests, they are located along rivers. Bayous, so these are brackish marshes that have both fresh and salt water inputs, and so they're kind of in the middle. pitcher plant bogs. So these are depressions in the landscape that hold water and have habitat for lots of cool plants that like pitcher plants and other carnivorous plants. Wet pine savannas. So when these are well managed, they look like pine trees on a field, but they actually have some standing water, and they provide habitat to a lot of cool animals. And then, of course, swamps. All right. So the wetlands are really important, and they serve as a natural solution in part because they provide us with lots of different benefits. They help to improve water quality, and they do this by preventing pollution and nutrient runoff from getting into our waterways. And this is the plants in wetlands can absorb these nutrients. They provide habitat for recreationally and economically important species. So you can think basically that's fish and seafood. Wetlands store carbon. So earlier when we were talking about the carbon forming a blanket in the atmosphere, warming the earth, wetlands help mitigate some of that by storing carbon in the soils. From when plants die, they're slow to decompose in wetlands, so that just holds the carbon there. And they also can help buffer against storms, which is very much related to sea level rise. So to talk about that a little bit more. So when we talked about sea level rise, they can exacerbate the effects of storms, and this could be hurricanes, tropical storms, or just storms that move off the Gulf onto land. And wetlands help protect against those by knocking down waves, where the waves just won't be as high whenever they get to urban areas. They slow the speed of water, so not only does it make the water less high, it slows it down so it's not as destructive. After a flood event, wetlands can absorb stormwater, whereas hardened infrastructure like roads, parking lots, those kinds of things, the water can pool and just sit there. Having wetlands can absorb it and reduce that flooding quicker. And wetlands are resilient to storms. So one fun fact, wetlands, 15 feet of coastal wetlands can absorb up to 50% of incoming wave energy. So not too much wetlands can reduce the damage from storms by waves pretty significantly. All right, so one way we use wetlands to help make our communities more resilient is with living shorelines. And so a living shoreline is a natural alternative to shoreline armoring like bulkhead and seawalls. So bulkheads and seawalls are typically put in place to prevent erosion, and living shorelines are a method of doing that same thing, but also keeping all those other benefits that we talked about. So on the left here, you have a picture of a living shoreline that you can see there's a green lawn right behind it and some apartment buildings. And then on the right is a bulkhead. When you compare the two, both can help with erosion control, but living shorelines are resilient to storms and other environmental changes. They can last forever if they're taken care of, but that doesn't include a whole lot of maintenance. Just, don't mow down the grasses, and which has happened in that one in the picture. And they provide a lot of the natural benefits that you lose whenever you put in a bulkhead. So this is just an example from comparing a living shoreline to a bulkhead in North Carolina that's before and after a storm. So on the left, you have the living shoreline, and on the right, the bulkhead. The red arrows are pointing to, it's just a point of reference, so you can compare with the after pictures. So after the storm, you can see on the left, the living shoreline is more or less intact. You might have lost a few of the rocks, but the grasses are all good. The property looks intact behind it. On the right, the bulkhead's gone, and so is a lot of the land that it was holding back. So properties behind marshes suffered 16% less annual flood damage. And this is from a study by Rachel Gitman. Right. So living shorelines, they're resilient and they're adaptable. So as sea levels rise, living shorelines can adapt to that. So how that works is if you plant some grasses along the shore and the water rises, the plants can move upslope with that water to their ideal spot in the tidal frame. And so not only these restored shorelines, but natural wetlands are adaptable too to this change in sea level, where they can migrate upslope and maintain that ecosystem. And so when we mess with the wetlands in different ways, so sometimes that can be just in like with boat wakes, or it can be we deprive sediment from an area. Many different ways we can mess up wetlands. Some large-scale wetland restoration and protection projects are put into place. So in this example, some oyster shell breakwaters were put out in front of this eroding shoreline to help keep it from eroding as quickly, or hopefully stop it. So this is another example from the Gulf Coast where there's a mix of living shorelines installations, oyster shell reefs, and also marsh creation. And what you can see in this picture is it's expensive, but it's worth it because wetlands provide us with so much protection and other ecosystem services. And there's a third figure to just show how that there is a lot of these projects going on in the area. So wetlands, the restored ones and natural ones, are going to have to deal with sea level rise. How is that going to work? It depends on a few factors. The first is that there's space for wetlands to migrate upland. So in this example that we already showed, there's not a lot of space for migration because there's actually these freshwater ponds behind the shoreline, which is why these breakwaters are helpful, because it's helping to keep those plants from having to migrate in the first place by breaking waves before it hits the shoreline. But we can limit the amount of upland migration by putting in roads and buildings and seawalls and things like that. So sometimes it's making space for the upland migration. And then second is that wetlands have to keep pace with sea level rise. So how can we tell if a wetland's keeping pace with sea level rise? Researchers use this method, or this tool called a SET, which is a surface elevation table. And so it uses a long rod that's driven deep, deep down into the soil, down to bedrock, and then these pins that the arrow is pointing at that says SET. The pins are used to measure over time how much the sediment surface has changed. And so that will give you an idea of how the marsh elevation has changed, but that's not telling you if it's keeping pace with sea level rise. So SET data is combined with data from tide gauge networks because the tide gauge will tell you what the sea level is doing, and the SETs will tell you what the marsh is doing. And so when you put that together, you can tell how a specific area in a marsh is doing, keeping pace with sea level rise. And so there are SETs all over the country. This map is just our inventory of SETs in the northern Gulf of Mexico. And you can see there are a lot of SETs in some places and not so many in other places. But so when you put this stuff together, you can get an idea of where things are accreting and where things are eroding. So in this example, the red arrows are where things are not keeping pace, and the blue arrows are where things are keeping pace with sea level. So if there are areas that aren't keeping pace, what can be done about that? So this is just a few examples of what can be done, but it is not an exhaustive list. So one thing is can implement projects to protect what we already have. So again, the oyster reef breakwater helps to protect that shoreline from further erosion, which helps the plants maintain their current footprint. Can do thin layer placement of dredge material. So in shipping channels or just any sort of area where large ships or boats need to go through, sometimes we have to dredge those areas out so that the boats can actually get through it.
And so this is the idea of using that dredge material, the sediment and dirt, and putting it on top of a marsh in thin layers to help the marsh keep pace that way. And then also we can incorporate all sorts of wetland data into tools and then use those tools to identify areas for restoration and conservation. So in this example in Weeks Bay, Alabama, you can see in the bottom right corner where we have this box that under the high scenario for sea level rise, that all that green is where it's projected to be a bunch of marsh. And so a planner might be able to look at this and say, okay, so maybe this is where we need to buy upland lands to make sure it stays available for upland migration, or maybe you can look at an area that's eroded a lot from the other pictures and say, okay, maybe this is a spot where we need to go and do a wetland restoration or a protection sort of project.
And with natural solutions, it's, hold on one second. With natural solutions, it's using what nature has there and harnessing that power and maintaining those ecosystems so that they can protect our communities. And then ordinance and policy solutions is more of the human-driven solutions and organizing our communities to look at how we can put things in place that would be resilient.
All right, so yeah, this is a little bit of a kind of beeline from some of the science that we've been throwing at you so far, but ordinances and policies actually have a lot to do with resilience, and they are a lot of the time incorporated into the discussions we've already been having about sea level rise and about those natural solutions. So I'll touch on that a lot in this section. But what I really want to stress is that these local governments at the city or at the county level are really leading the way when it comes to increasing resilience, especially in this region of the northern Gulf of Mexico. So just to give you an idea of the players at these levels, we have the county level where you have county commissioners or superintendents or parish presidents in Louisiana, for instance. They can encourage focus on these resilience issues within their area. And then alternatively, you also have county programs like your utility authority who can individually address and incorporate resilience into their decision-making and planning. So this works in addition to the county commissioner or superintendent or president directing their county and their county programs towards increasing resilience. And then at the city level, we have city councils, of course, and other elected officials like a mayor, and these people direct a city or a town's position and their involvement within the resilience spectrum. So they really set the pace for everyone involved in the city. And then city staff often work in addition to this to address issues specific for their department. So you'll see planning departments, environmental departments, recreational departments, and plenty of others, which can all be involved in city level resilience conversations. And so us with the Sentinel Site Cooperative, you heard a little bit more earlier with some of our partners, and we definitely try to work with pretty much all of these types of folks. I think we have a representative from each of these bullets, at minimum only one, definitely a lot more, and various of our teams and advisory committees for various of our projects. And so we really do focus on working with these groups to increase resilience in the ways that they have available to them. And that's in part ordinances and or policies, because all of these entities can do that. And so ordinance is definitely an unknown term to a lot of folks, so I wanted to kind of define that as well as what a policy is. So an ordinance is going to essentially be a law or a rule. It's a regulation, so it's essentially a requirement that you have to follow. within that city or county's jurisdiction. And then a policy is going to be a little bit different from that. So it's going to be a course of action. So it's more of a procedural intention. So you can set a policy which then ordinances will be developed because of, for instance. And both of these can be used for different portions, and I'm going to go through some examples of how they can be incorporated into city and county projects. There are a lot of different ways. This is definitely not a full list, but just to give you some ideas of what these look like. Just to start, I will say that I'm focusing on city and county level, those local government capabilities, but federal and state programs can apply to all of these as well. They can provide funding for these projects as well, and can really make it possible for those local governments to do this work as well as do it on their own. So open space requirements can be very helpful in helping the land reabsorb sea level changes or stormwater events, things like that. Having open space in general can be very good, and that's very closely related to zoning and land use regulations, which are going to be used for a variety of different situations. Zoning and land use can tell people how and where they should be building and what they should be building in what areas and all of that sort of thing. What areas maybe are the best for conservation and should be left alone. That's where those regulations can come into for ordinances especially. The building standards can be very important, especially in our area where we're being hit by a lot of hurricanes and tropical storms. I know other areas have building standards for different situations as well. Some might be for different other hazards, but for us, we follow a lot of fortified standards in some areas, which are these higher level building standards that will help your home or a business or anything like that be maintained after a storm and during a storm. And that's actually been, increased building standards has been something that a city over in Orange Beach, Alabama, just over there on the coast, has been doing a lot of. They have a lot of ordinances requiring people to increase their building standards, and they also have one for freeboard requirements. And freeboard is essentially the requirement for the height to build to. And so freeboard is essentially an additional height added on to what is required by your floodplain to make sure that you're getting kept out of a floodplain that will be ever increasing in many areas due to sea level rise. So they were able to kind of incorporate that into that. And then we also have setbacks and riparian buffers. And so these are commonly used with regards to the natural infrastructure, like we were just talking about with natural solutions. So setbacks are, for instance, going to help reduce the amount of, basically the amount that people are getting into the area of, for instance, marsh migration. So having those setbacks will allow for that space. Those riparian buffer zones will be very helpful for that. And there's a community also in Alabama known as the City of Daphne, and they have been doing a lot of great work there as well, so that their natural infrastructure can continue to protect them now and in the future. And they've also been doing a lot of low impact development, or LID. And low impact development is essentially what it sounds like, where you're going to be trying to make sure that all of the development you're doing is going to be what's more green development. And so you're looking at green roofs or permeable pavement, anything that's going to be taking less of a toll on the environment and going to be allow the environment to do what it does naturally as best as possible.
And community planning solutions are the opportunity for organizing those natural solutions and the ordinance and policy solutions to bring them together in a way to incorporate all of it to effectively meet the needs of your entire community.
Yes, this is a very difficult process, and it is happening in many different ways, and I'll cover a lot of that. But planning can be extremely difficult because it is taking in all of these different fields, and you need to have a lot of different people at the table. You need residents, you need people from every department of your government office, whether it be county or the city. You need to bring the scientists in as applicable. You need to bring the experts in and make sure that everything is being posed for success, so that you don't run into any mishaps like this building did. And so I'm going to cover a few plans that are available and that I do recommend, if you're interested in this sort of thing, that you check out and see if your community has any of these and what's all included in it. So the first I'm going to cover is the comprehensive plan, which is also commonly known as a strategic plan or a master plan. They're pretty much all the same thing. And these are going to be very all-encompassing, as the name suggests. These are going to be taking into account all of the departmental needs for all of the departments within a community. They're going to be all working together, bringing in outside expertise as is required. They'll also always be run by the public during public meetings. If that's something that y'all are interested in attending, master plans can be updated routinely. It changes community to community, but it's always worth looking at and seeing when it needs to be updated, because that's one of the things that we encourage folks thinking about with sea level rise, is that these risks that we face are changing. And so a lot of comprehensive plans should be taking into account sea level rise and how they're going to be changed eventually, but they're not going to be changed yet. So we need to make sure that we're all keeping pace for that with our planning efforts in our community as well. And that leads into hazard mitigation planning, which is a little bit more focused. So hazard mitigation plans will look different, again, for every community in the Northern Gulf. A lot of them are very focused on flooding and on storms, as you may expect. But hazard mitigation is then definitely very important to have sea level rise incorporated in it, making sure that we're aware that high tide flooding will increase, like we talked about in the introduction, and also that the storm surge is going to be increasing, making sure that we can put in some policies in place within these plans so that our riparian buffers are allowed and that our marshes are able to migrate inland as needed and continue to protect us and mitigate these hazards for us. So all of that sort of thing can go into play with hazard mitigation planning. And then just to get even more narrow in a way, but not in all ways, we have the sea level rise plan. And these are less common to see. They do exist. For instance, there is a city in Mississippi, known as the city of Ocean Springs, and they actually have a sea level rise plan that has been already making some progress within the community, helping adjust their knowledge of how and where they should be building. And so that's really how this works, is that these plans, while it's focused on a specific issue, is still including folks in a lot of different departments, and is also should be including the community as well, so that we're all aware of these changing levels of risk, and what kind of sea level rise, what kind of increased flooding we should be prepared for, and all of that, making sure that each department knows, making sure that utility authority is aware that they should be considering these changes as well, and all of that. So there are a lot of different ways to do community planning. I will say that from working with the Sentinel Site Cooperative, one of the things that we're learning is that there's not really a wrong way to plan for sea level rise as long as you're planning for sea level rise.
And so to look at what's happening in the northern Gulf of Mexico, to see where we're working, we're helping communities and people within those communities get access to the information they need to have to plan for sea level rise, to get technical support with what that might mean for then implementation for sea level rise. So for access, this is getting that information about sea level rise and specifically tools to help visualize that. So one tool for sea level rise is the NOAA Sea Level Rise Viewer, and this shows what will high tide look like. So on the left-hand side, there's a little ruler with feet, and so with this visual mapping tool, you can change the sea level rise by dragging that viewer to see where inundation of water might change in a high tide with sea level rise. Another tool that's specific for the Gulf of Mexico is GOM Surge, which is a storm surge flood viewer. And so in this tool, there's a slider bar. Right now it's on the right-hand side of the image, a gray bar. And so when you slide this bar to the side, it shows storm surge on top of 4 feet of sea level rise and how that is a change in the floodplain, and that floodplain is used as a planning standard. So having this information about change in inundation depth will help communities plan for what sea level rise might impact in a case of a storm. Another tool is this one that shows wetland migrations. Where will wetlands go? On the toolbar on the right-hand side, there are different types of wetlands. And with this tool and the different changes, you can see where wetlands may move under different sea level rise scenarios, as well as different urbanization scenarios. And a last tool for today is Hydro-MEM, which shows salt marsh productivity and the footprint of that salt marsh. And so in these results, it is a model that forecasts where the overall footprint of the marsh may be, as well as how productive that marsh is. And so this allows, like Sara mentioned in the natural solutions area, to look at maybe protecting land that's upward if that marsh may move that way under different sea level rise scenarios. And for technical assistance, this is how to deal with uncertainty in scenarios when planning.
So this one example we have around technical support is pretty common, I would say, across the board, where people see this big range. Again, these are the same scenarios as before, but these are the global averages. And that's a pretty big range, right? It's 1 feet to 8 feet. And so there's this idea that maybe we don't know what we're doing as scientists if we're saying this is a big range that might happen. But that's not actually the case. The reality is that this is the range of what's scientifically possible. We could see anywhere from the low scenario all the way to the extreme scenario. But because of the research we've done and the science that's available, we know that they're not all as likely. So we have tables like this one. So these are those same scenarios, low through extreme, and depending on which carbon emission scenario, because as we learned earlier, the amount of carbon in the atmosphere, thickening that blanket will make the waters warmer. Depending on those, we can see the likelihood of each of these scenarios under different carbon emissions. And so if we look at this RCP 8.5, which is no change in carbon emissions, the low and intermediate low scenarios are very likely to happen. This means that the low is 100% likely to be met or exceeded. But moving up the chain to some of these more extreme scenarios, their probability of occurring is a lot less. And so we can use this information to work with communities to reframe the question. And so we start talking about flood risk tolerance. So if you have a low tolerance for risk, that means that it would have a major impact on your facility or your infrastructure, whatever it might be. If you have a moderate tolerance for risk, then that means it would have a moderate impact if it flooded. And if you have a high tolerance for risk, then it would have a very minor impact. This would be like a shed or a small boardwalk that people use. And so to sort of clarify the link between these two, if you have a low tolerance for risk, so say a hospital or a power plant, something that provides a lot of resources to a lot of people in the community that you want to be there for a long time and has a really critical role, you're going to plan for these high and extreme scenarios. They do have a low chance of happening, but they could happen. And if they did, it would have a really big impact. So you want to be prepared for that. But if you have a more moderate tolerance for risk, so for example, when I was buying a house, well, that would have a big impact on me. It wouldn't be the end of our society if the house flooded. So I went with the intermediate and intermediate high scenarios because it has a moderate chance of happening. And so I wanted to make sure that I was prepared for that. But if you have a high tolerance for risk and it's not going to be a big deal if it floods, you're only going to plan for those things that you know are definitely going to happen. You're going to invest the resources to make sure you're avoiding the certainty there. So just to make sure this all makes sense and it fits together, say we're building a hospital in a coastal county. So the risk tolerance for that, it's very important to the community. We want to make sure that it works even in critical times or floods. And so you would have a very low tolerance for risk. So because it has a low tolerance of risk, they would be looking at their high or extreme scenarios to plan for. And so if you go to the curves for that county, not the global average, but for that county, what their projections are for sea level rise, and you start in 2020 and say you want your hospital to last 50 years, then you move forward to 2070, and you zone in to the high and extreme scenarios. So now, instead of the people who are working on this, the architects and the planners and the builders in the hospital, looking at 1 foot to 10 feet, they're focusing on looking at sea level rise that'll be 4 to 5 feet in the next 50 years. So then we can go back to those resources we heard about before, those tools where we have access to sea level rise information. We can see, okay, if storm surge occurs, is it going to block off major thoroughfares to this hospital? Is the high tide going to impact parking or things like that? And just make sure that the future conditions are being included. And so this is an example. This is just one thing that we do often with communities, whether it's planners, utility authorities, whoever it might be, to help them not only have access to these local projections, but make sure they're using them in an informed way.
And so how we use that implementation and what does it look like? We'll hear from some specific projects in the Northern Gulf.
Right, so access is of course extremely important, as well as technical support, but it definitely is helpful to see how all of these things come together to lead into the actual implementation of getting these things done. So with what it looks like, I'm going to first highlight the fact that, excuse me, there we go, that these things are actually happening. I think there's a lot of folks out there who talk about how we need to do these things and we need to do it, but they are actually happening. We have these stories of success, these case studies showcasing it that we can all learn from and continue to do in the future as well. So I'm going to tell you all about a couple of projects here. One is from Magnolia Springs in Alabama, and the other is from Florida over in Apalachicola. And these pictures over there on the right are both from those projects. On the bottom there is from the Magnolia Springs project, where you can see them looking at one of those tools on a future storm surge that we were looking at earlier. And then the one above that is Apalachicola, and they're looking at doing a assessment on a building right there, one of those historic buildings. So to give you a quick synopsis on what these are doing, first I want to cover the players. So this is for the Magnolia Springs project. And you can see here that those first two logos there are very more into the science and the technical aspects of all of this sort of thing. And then over on the right here, we have county and a county sanctioned program. And one of the other things that this project has done a lot of, that's not really, it doesn't have a logo, but they do a lot of community involvement. There was a group called the Friends of Magnolia River, who's a community group that really pushed this project through to be where it is now and actually happening. So this was a very multidisciplinary project. What it is doing is it's exploring the feasibility of constructing wetlands as a regional detention system. And so what that really is talking about is bringing in, again, the natural infrastructure that we were chatting about before, showing how it can reduce flooding now as well as in the future, and it can also provide that infrastructure to reduce sediment and pollution concerns that are going on as well. And this is not going to stand alone. They're going to take this feasibility study and then they're going to work on obtaining future funding so that they can actually create this wetland and get those benefits from it. Of course, as long as the feasibility study comes out approving that that's the right direction to go. We'll see, but things are looking good so far. They're in progress. They're right through the first quarter right now. And so I want to bring this back all together with all of this stuff that we've been throwing at you for this past almost hour now. We've been talking about community planning, natural and ordinance and policy solutions, as well as these actions, right, these implementations. So I want to show how this project is addressing all of that. First, in the community planning element, we have a watershed management plan. So this was an action undertook in the Magnolia River area, which Magnolia Springs is within. And this watershed management plan really sparked the ability for this project to happen, and it was done within the community. And so for what it directed is towards our restoring of the wetlands in the area. Ordinance and policy was not directly yet done, but we're working on that would be the direction that this project would take. And then for the action, we have the actual feasibility study that this project is doing, and a future action being the actual construction of the wetland. So then we have our other project with Apalachicola, Florida. Again, this was a very diverse group, a lot of different sectors coming in. We had the city of Apalachicola, as well as Apalachicola National Estuarine Research Reserve, which brought in a lot of the science and communications that they're working on within the community. And then we also have some folks involved in construction, as well as some historic preservation architects, because this project is looking at assessing historic properties for risks related to sea level rise, as well as associated flood hazards. So this is building off of previous work that Apalachicola has undertaken. They've done a vulnerability analysis, which was supported by the state of Florida and NOAA, the National Oceanic and Atmospheric Administration. And instead of letting the vulnerability analysis report just kind of sit around and collect dust, they took it and they actually cared about, this is a growing hazard for us with sea level rise and increased hurricanes and everything like that, increased storm surge. This community was hit rather badly by Hurricane Michael the other year, and so this really hit home, and they were excited to do this project assessing these properties. And with this assessment, they're going to get specific recommendations and cost estimates for potential mitigation measures like flood proofing or elevating these vulnerable properties, and they're going to use this information to obtain further funding. And so where they are on this resilience wheel, if you will, is for community planning. They did that vulnerability analysis that involved the whole community. A lot of expertise went into that. And then for the solutions, they're looking at adapting these historical buildings. This came out as something that was very important for them to do. And then for their actions, they're actually identifying and pricing these mitigation measures, and then they're going to be implementing that by applying for the future funding. They're actually going to go through FEMA for that, and they already have it all prepared for when they finish this assessment. So one of the things I want to address before we start finishing up here is that if you notice in these projects, neither of these are huge projects trying to take on the whole world or anything like that. And this comic is showing a little devil over there on the chair, and he's saying to the artist, if you can't finish this in one shot, you shouldn't start. And we have our artist over there with a giant slab of marble, and he's saying, I don't think you're understanding how this works. You're not grasping it. And that's really kind of the mentality that we live by in the cooperative here, is that these issues, this whole thing of sea level rise can seem extremely daunting. But by chipping away piece by piece, doing these projects, it's going to snowball effect and become something wonderful.
And so actions that you can do for you, with your family, and as your community can help you get into this snowball effect. For sea level rise actions for the community and the family, have open discussions with your friends and family about flooding issues that you may have experienced, as well as look at what your future risks are. Have these conversations. Also, reduce paved areas in your communities with either permeable pavement or gravity to help with stormwater management. Get flood insurance, even if it's not required. It helps protect your home, as well as helps our flood insurance system be robust. With your family, create a stepwise emergency plan and communicate it. We have an example of a community that deals with flash floods, and not everybody knew what to do in the case of a flash flood. So having a plan before something happens helps you be prepared in any case. And then finally, you can check out Project Drawdown for more information on climate solutions that are both large scale as well as small scale. And then student-driven sea level rise actions. Go to your town hall meetings and talk to your community leaders. If they're already talking about sea level rise, great, keep that conversation going. If not, bring that up. Show them that it's important for your areas to understand what your future risks are. You can plant rain gardens near your home or community, and these are areas that have plants to help absorb some of that water from rain events and help with stormwater management. And you can also, as students, look at how your school can be more resilient. There's an example of a project in New York. The Resilient Schools Consortium is a NOAA and FEMA-funded education program where middle and high schools in coastal Brooklyn learn about coastal cities that are impacted by climate change. And then these students walk around their school building and they assess the school's infrastructure and report on damages to identify future weak spots or problem areas. Another student who's doing great work for ocean conservation is Miles from Kids Saving Ocean. When he was 6, he wanted to donate his allowance to ocean conservation, but working with his parents, he has started a company selling stickers and t-shirts designed by him so that he can have a continuation of donations towards ocean conservation. So it wasn't a one-time thing, he's doing a long-lasting impact. For additional resources, you can check out our website, Northern Gulf of Mexico Sentinel Site, ngomssc.org. We also have a YouTube channel with some case study videos, including that community with the flash floods and their planning. You can check out NOAA Tides and Currents to look at the water levels with high tides and low tides, as well as the NOAA Sea Level Rise Viewer to see how sea level rise might impact high tides near you. There's the Marsh Migration, Hydro-MEM, and GOM Surge tools that we talked about, as well as Project Drawdown. So to end with an An adapted quote, we don't need a handful of people doing resilience perfectly. We need millions of people doing it imperfectly. These small projects really have a big impact. So thank you all for listening. My name is Sonia and I have my contact information here, but we also have time for questions.
Okay, thank you very much, presenters. I'll note that the resources that they had listed on the last slide, they provided to us, so we will have those up on our website tomorrow, along with a recording of this webinar. So if you're looking to look into those links more, or if you know somebody who maybe wanted to participate in today's webinar or would like to view it at a later time, it will be up on our YouTube channel starting tomorrow. We'll also advertise once it's up on our social media site, so you can go and see it. So now is your time to ask these four very knowledgeable individuals any of your questions about the sea level issues that they mentioned in their webinar, or even if you just have a general sea level rise question for them. So as I noted before, go ahead and type your questions into the chat box, and then I'll be able to read them aloud. We'll note we had, during the presentation, we had one person ask if you could maybe explain a bit more what you meant by social vulnerability when you had those four graphs up about the different regions of the U.S. and how they were going to be impacted, how individuals would be impacted by sea level rise?
Yeah, absolutely. So in that particular case, when we're talking about social vulnerability, they were using what's known as the Social Vulnerability Index. And so this indexes together, I think 13 or 14 different indicators of potential social vulnerability. So this can be education, age, a whole wealth of demographic information to identify people who, apart from sea level rise, already are vulnerable to other social issues. And then they were looking at the compounding effects of that social vulnerability with sea level rise and how sea level rise would make that even worse. So when we're talking about social vulnerability, that's what we were looking at.
Okay, any other questions? Okay, maybe while we wait for a few questions to be entered, I would like to say that I very much appreciate the second half of your presentation. At the finals competition for the NOSB, we do what we call our science expert briefing, where the students discuss sort of policy implications and the science that is required to place those policies. It's a mock congressional briefing, and I do think that they will find that second half of your presentation very helpful as they sort of look at what their, they take different roles, whether they're a scientist at an NGO or with a federal agency or a local state agency. I think they'll find that really helpful as they craft their recommendations for topics. And I would not be surprised if our SEB somehow was related to sea level rise. We'll see. We typically try to choose a piece of policy that is being brought up in the current Congress or has recently. So we'll see. But if it is, this will definitely be a resource for those teams. The recording will be posted tomorrow, and it'll be up on our YouTube station. And as I said, we'll make sure to have it up on our social media as well, the link to it. Any other questions? Okay, well, now if there's no questions, we'll let our presenters go. I want to thank them once again. Hopefully we will have at least another presentation for our webinar series. As you know, we're getting into the holidays, so people's schedules are kind of crazy, so I'm hoping that the next one will be in early January. So be on the lookout for emails and social media posts about it so that you can join us once again. And As I noted, this recording will be posted on our YouTube station. Please share it broadly for anyone who might be interested in learning a bit more about sea level rise and how it can be addressed locally, to states, and nationally. Thank you, everyone, for joining us today, and I look forward to having you participate in future webinars. Thank you very much.
Thank you.